Hello everyone. Now we are going to discuss about EC8561 transmission lines and RF systems subject video, and this is unit 1 transmission line theory, and this is the syllabus for unit number 1. And this we are going to discuss about wavelength and velocity of propagation. Generally, we know about wavelength and velocity of propagation. It's nothing but for any signal we have a wavelength and also velocity. If it is propagating, definitely it's having velocity. And the propagation constant and the characteristic impedance are called as the secondary constant of primary line. Already we know about the primary constants, resistance, capacitance, inductance, and conductance are called as primary constant, and the propagation constant and a characteristic impedance are called as a secondary constant. And already we know about that propagation constant is always a complex quantity. It is represented in terms of gamma is equal to alpha plus j beta, and where alpha is the attenuation constant and beta is the phase constant, and simply we can write the value of gamma is equal to root of z into y, where the value of z is equal to r plus j omega l and y is equal to g plus j omega c. And the characteristic impedance of the transmission line is also a complex quantity. We know about that how you wrote gamma is equal to alpha plus j beta, like z0 is also a complex quantity, and the value of z0 is given as root of z divided by y, right? I can substitute the values of z and y. Z0 is equal to root of r plus j omega l divided by g plus j omega c, and the propagation constant of gamma is equal to alpha plus j beta. And we can substitute the values instead of z and y is equal to root of r plus j omega l into g plus j omega c, and we can equate the left hand side and also right hand side. Alpha plus j beta is equal to root of rg minus omega square lc plus j omega into l plus lg plus rc. Just you are going to multiply the complex conjugate, just you are going to multiply the complex values, right? That's all. And we can equate the real part imaginary part, so that we are going to make the square value on both sides. So left hand side alpha plus j beta whole square, right hand side the square bracket will goes off, and a plus b whole square formula we have to expand by using a plus b whole square formula. We have to expand the left hand side, so alpha square plus beta square plus 2j alpha beta is equal to rg minus omega square lc plus j omega into lg plus rc. And first of all, you have to equate the real parts, then we can equate the imaginary parts. If you are going to equate the real parts, left hand side alpha square minus beta square, right hand side rg minus omega square lc, and beta square goes to right hand side plus beta square, alpha square is equal to beta square plus rg minus omega square lc, and we can take the value imaginary part value. Getting imaginary part, 2 alpha beta is equal to omega into lg plus rc, and I have to make the square. 4 alpha square beta square is equal to omega square lg rc whole square, and we need the value of beta square only, so just read the equation. Alpha square plus beta square is equal to omega square by 4 into lg plus rc square, and already we have the values of alpha square here. Substitute the value of alpha square here, I can write the value. So this is the value of alpha square plus rg minus omega square lc into beta square, right? Omega square by 4 into lg plus rc whole square. Just multiply the beta square into beta square, beta power 4 plus beta square into rg plus omega square lc minus omega square by 4 in minus lg plus rc whole square is equal to, just rearrange the equation, and this is like a quadratic equation. The solution for a quadratic equation, b square is equal to minus b plus or minus root of b square minus 4ac divided by 2a. Based on the formula, we are going to expand the values here. Here beta square is a constant value, right? It's a variable value, so coefficient of the beta square is 1, and the beta value, the coefficient of this beta square is rg minus omega square lc, and the constant value is minus omega square by l lg plus rc whole square, right? Here based on the formula, x is equal to minus b plus or minus root of b square minus 4ac divided by 2a. Here the x is 1 and a is rg minus omega square lc, and c is omega square by 4 into lg plus rc whole square. And by neglecting the negative values, we can write the positive value. Beta is equal to, just we take the square root value, beta is equal to omega square lc minus rg plus root of rg minus omega square lc whole square plus omega square lg plus rc whole square by 2, and This is the value of alpha square is equal to beta square plus Rg minus omega square Lc, and you can substitute the value of beta here, and alpha square is equal to omega square. Just so you have to substitute the entire value. This value will be substituted here, right? And after taking the LCM value, here we have divided by 2, and here we have a normal value. Just we have to take the LCM value 2 Rg minus 2 omega square Lc, and here we have a plus, here we have minus 2 omega square Lc. So one value gets cancelled. Here we have plus Rg, here we have minus Rg. So Rg minus omega square Lc will come. Seconds. We can write Rg minus omega square Lc plus root of Rg minus omega square Lc whole square plus omega square into Lg plus Rc whole square by 2. And left hand side we have alpha square. If you want to alpha, take the square root value. We can write the square root of Rg minus omega square Lc plus root of Rg minus omega square Lc whole square plus omega square Lg plus Rc whole square by 2. And for a perfect transmission line, the value of R is equal to 0 and G is equal to 0. We can substitute the condition here, and beta square is equal to omega square Lc, and beta is equal to omega root Lc. And this is the velocity of propagation is given by v is equal to lambda into f, and where we can write we substitute the value as lambda into f, multiplied by the value of 2 pi, and we can replace the value v is equal to omega by beta, where beta is equal to 2 pi by lambda, omega is equal to 2 pi f, and substitute the value of beta here, and beta is equal to omega root Lc, and v is equal to omega by omega root Lc, omega gets cancelled, v is equal to 1 by root Lc, and this is the velocity of propagation ideal wavelength line. And wavelength is nothing but the distance traveled by the wave along the line while the phase angle is changing through 2 peridians, and it is called as wavelength. Beta is equal to 2 pi, and lambda is equal to 2 pi by beta, or lambda is equal to v by f. That's it. Thank you.